All right, welcome to Ace Your IB Math exams in 10 weeks. This is week number 8. We're almost there, just 3 more to go, counting this one. I'm Bruno, the IB Math teacher. Hopefully you know me. If you don't, I used to work as the head of department in one of the most prestigious IB schools in Brazil, also an HL math teacher, and also an IB math examiner. For this May 2026 cohort, I've decided to launch a 10-week course, or you might call it a 10-week challenge, where we go through each week through 5 different questions from all 5 topics in IB Math: number and algebra, functions, trig, statistics, and calculus. All questions are demanding. They're mixed. They're paper 1, they're paper 2 questions, they're medium level ones, they're hard ones. So this is a way for us to mimic the real scenario. Everything can be found in the description of this video, the PDF, the links for the other weeks, for the other videos. Do share these resources with your colleagues so you guys can study together. Let's get to it. Let's get through week number 8. All right, so we're going to start exercise 1, which is a proof exercise using 2 different strategies. We're going to solve it using 2 different strategies. The first one is to think about all the possible cases for A being either a even number or an odd number, so we're proving by exhaustion. However, the second strategy, which is more sophisticated algebraically, does work as well. It is valid as well. So let's start with considering these 2 possible cases. If A is even, then we have this. If A is odd, then we have this other thing. So let's tackle it. So let's call this method 1, and of course you only need to use one of these methods to solve this problem. We're going to consider that A is an even number, meaning that A can be written as 2 times K. That's the way that we represent an even number. K, of course, being also a integer. If that is the case, A cubed minus A plus 1 is equal to 2K cubed minus 2K plus 1, which is 8K cubed minus 2K plus 1. And we can factor out a 2 in these first 2 terms, getting 4K cubed plus 1. Now, given that this is even, and whenever we add 1 to an even number, we get an odd number, Now, considering A to be an odd number. And the way that we represent odd numbers is by writing them as 2K plus 1 or 2K minus 1. That also works, K being an integer. In this case, our A cubed minus A plus 1 is equal to 2K plus 1 cubed minus A, so minus 2K plus 1 plus 1. And expanding 2K plus 1 cubed, either by foiling or using Pascal's triangle, we get the following, which is equal to 8K cubed plus 12K squared plus 12K plus... Léo, só vou consertar aqui esse outro 12 plus 6K plus 1. And given that we have negative 2K minus 1 over here, we can simplify negative 1 with 1. So we get 8K cubed plus 12K squared plus 4K now plus 1, which means that we can factor out a 2 in the first 3 terms. So 2 times 4K cubed plus 6K squared plus K plus 1. This is even. Even plus 1 is an odd number. So which is odd? Therefore, A cubed minus A plus 1 is odd for all positive integer values of A. Now let's use a second method to prove the same thing, and you get to decide which one you prefer. Starting with A cubed minus A plus 1, we can factor out an A in the first 2 terms, write this difference of 2 squares as A plus 1, A minus 1, and given that these are consecutive integers, either 1 or 2 of them is going to be even, which means that the whole thing, A times A plus 1 times A minus 1, will be even. Therefore, this whole yellow box is even, and even plus 1 is an odd number. Do explain your reasoning. This is even because at least one of the terms is even. Therefore, even plus 1 is an odd number. And there you go. Alright, so in this question number 2, you're going to need to be super comfortable with not only finding equations of lines, but also how to deal with composite and inverse functions. Now, what we have here is a function that consists of 2 line segments connecting these 3 points. So 0, 10, 4, 0, and then 4, 0 to 12, 4. If we're trying to evaluate f of 2, the first thing that we need to find is f of 2. And remember that f of x is a piecewise function, therefore all of this belongs to f of x. Therefore, f of 2, we can see from the graph that it's equal to 5. If the graph crosses the grid at that particular point, then you're fine. You can, by inspection, grab that value or use that value. However, when it doesn't, you cannot make any assumption. And that's exactly what's going to happen in the second step of this exercise. So we do have f of 2, which is equal to 5. Therefore, we need to find f of 5. In this case, it's pretty clear that f of 5 will be 1 over 2. However, as I mentioned, and let this serve as an example for other IB math exercises, let's not make any assumption. Let's actually find the equation of this line segment. So we can then replace 5 in x. Of course, we're gonna get half as a result, but let's get there analytically by taking delta y and dividing by delta x, which means 4 divided by 8. And if the slope is 1 over 2, we can finish this by finding b, replacing one point that the line crosses. So that could be 4, 0 or 12, 4. And let me replace 4, 0 just because it's easier. Now we get b equal to -2. Therefore, the equation of this line segment is 1 over 2x minus 2. And this is, of course, valid from 4 to 12. Now we can find f of 5 by replacing 5 into the x value, which gives us -half. So f of 2 is -1 over 2. Now we have another function now that we need to consider. G of x is equal to 2x plus 1 over x minus 1. And if we're trying to find the solutions for the equation g of f of x equal to 3, remember that the last thing that is done in this process is to evaluate g of something. And in this something, of course, is f of x at some particular point. But we know the result for it. The result is 3. Therefore, we need to have something here, which when you input into g, produces 3 as a result. Now, producing 3 as a result in g of x means that you're not plugging in 3 into the x values or into x over here and over here. What it actually means is that the result is 3. Therefore, this g of x is going to be 3. We need to find the x value that produces 3 as a result. And that means that we need to find where 3 is equal to 2x plus 1 over x minus 1. After cross multiplying, we get 3x minus 3 equal to 2x plus 1. Therefore, x is equal to 4. So whatever shows up inside over here, well, that has to be equal to 4. Therefore, this question mark, we know it is equal to 4. And now we have a different question to address, which is, where is f of x equal to 4? Now, again, we're not placing 4 into x, but we're actually reading what the input should be in order to get 4 as a result. And f of x is equal to 4 over here and over here. Now, we can clearly see that when x is equal to 12, we do get 4 as a result. That's the edge of this line segment. However, we cannot see precisely what the second value is, which is this one. So let's call these points A and point B. We do have point B, so now we need to find point A. So f of x is going to be equal to 4 at x equals, or when x is equal to 12, and when x is equal to something. We're going to find that something right now. Using a similar process, we're going to find delta y and delta x. In this case, the line is decreasing, therefore the slope will be negative. We have -10 over 4, which is the same as -5 over 2. So y is equal to -5 over 2x plus some constant b. Let me just call this c because we used b before. And now we plug in any points that this line segment crosses, for example, 0, 10 or 4, 0, which are the edges actually. So we can find c. So let me use the points 0, 10. So 10 equals -5 over 2 times 0 plus c. c, which is the y-intercept, is equal to 10. So everything makes sense. It should be 10 because that is the y-intercept. So the equation of this line segment is -5x over 2 plus 10. And this is valid, of course, from 0 to 4. Now, when is this equal to 4? Well, 4 equals -5 over 2 times the x value, which is this value right here, which we're going to find, plus 10. So -6 equals -5 over 2x. Therefore, that second x value is 12 over 5. You see, this looked like a harmless exercise, but it turned out to be trickier than expected. The coordinates of this point are 12 over 5, 4. So we have two different solutions. Now, if you want to check if this actually makes sense, if this actually produces 3, you can always double check, of course. So for example, let's take these two scenarios into account when x is equal to 12 and when x is equal to 12 over 5. So for x equal to 12, we have g of f of 12. We know that f of 12 is 4, so we have g of 4. And g of 4 is 2 times 4 plus 1 over 4 minus 1, which is equal to 3. So it works. Now, using the second case, we have g of f of 12 over 5, which is g of 4, given that this is the point 12 over 5 comma 4. And we know that g of 4 is equal to 3 because we just found that. So that's pretty much it. In this question number 3, we have a trig question, of course, topic 3, trig, that involves area of triangles, it involves the cosine rule, and a trig identity. So lots of concepts inserted into the same question. So let's tackle it. We know for a fact that the area of this triangle is 42. We have sides x plus 2, which is the shortest one, and the other ones are 2x and 3x minus 1. Now, using the formula for the area of the triangle, we're going to write down an expression for sine of theta in terms of x. And in the area, or in the formula of the area of a triangle, we do have sine of something. In this case, it's going to be sine of theta there. So let's apply it. When you're using the formula for the area of a triangle, do know, of course, that between A and B rests angle C. Angle C is there. It's the angle in between these other two sides. So we're not going to use, in this case right now, x plus 2 in this formula. So the area is 1 over 2, 3x minus 1 times 2x times sine of theta, which is equal to 42. We know that the area is 42. We can simplify 2.5. And given that on the left-hand side, we have x times 3x minus 1 times sine theta, and on the right-hand side, we have 42. Therefore, we can write sine of theta as 42 over x 3x minus 1. Now, we're going to apply the cosine rule to write down and simplify an expression for cosine of theta now in terms of x. When we're applying the cosine rule, this side and this angle, they're opposite to each other, which means that we're going to use these as the side that shows up on the left hand side, and this is the angle that shows up on the right hand side of this formula. So we have x plus 2 squared equal to 3x minus 1 squared plus 2x squared minus 2ab cosine of c, or cosine of theta in this case. So we have x squared plus 4x plus 4 equal to 9x squared plus negative 6x plus 1 plus 4x squared. And by writing 3x minus 1 times 2x as 6x squared minus 2x, we get negative 2, 6x squared minus 2x. All of this times cosine of theta. Now we can simplify these terms, writing them as negative 12x squared on the left-hand side of this equation. Also the x's, so plus 10x, and simplify the 1 with the 4. So plus 3 equal to negative 2, 6x squared minus 2x cosine of theta. Now cosine of theta can be written therefore as negative 12x squared plus 10x plus 3 over negative 2, 6x squared minus 2x. So there you go. This is an expression of cosine of theta as a function of x. Now in exercise number 3, we're going to gather all this information, sine of theta and cosine of theta, and by using the trig identity sine squared plus cosine squared equals 1, we're going to find the value of x. Now do remember that this is a paper 2 question, so you can use your calculator, and there will be no other way actually. And you can solve it, you can find your x value using one of these two possibilities. You can either graph it, or graph the equation, or the left and the right hand sides, or use the numeric solver in your calculator to find the x value. So either one of those is fine. So what do we have in question C? Sine squared plus cosine squared is equal to 1. Therefore, we're going to square this guy, and we're going to square this one as well, and place it over here. Now using the numeric solver, and careful when you're inputting this equation into your GDC, because it's very easy to make a typo. And by the way, you can always move this 1 to be on the left hand side, so you have 0 on the right hand side. So you get this. So let's type it in. And by selecting an appropriate interval, guessing for example at 10, we get approximately 5.86. And with this in hand, we can find what cosine of theta is by plugging 5.86 over here, over here, over here, and over here. And we get a cosine of theta equal to 0.9018 ... which means that theta, which is the arc cos of that, is approximately 25.6 degrees. All right, so exercise number 4, the longest one in this list. Let's take it slow so we get it, so we get every step of this exercise. So here's the scenario. Long story short, you're escaping a zombie attack. And in order to escape, you enter a dark room. You suddenly notice that in that room there are 9 other people, so you and other 9. You're stuck inside, you see a light switch, you turn it on. Now, given that in this apocalyptic scenario, there's a 19% chance of someone having become a zombie, and by the way, you're not a zombie, don't worry. What is the probability that from those 9 in the room, at most 3 of them are zombies? Now, this is a typical binomial distribution. There are 2 possible outcomes, which are zombie and not zombie. The probability of success, which by the way is 0.19, the probability of being a zombie. I wouldn't consider that as success, but we can use that rationale. It doesn't change, the probability is 0.19 and that's it. And also the events are independent. Whoever got the virus and that's it. Now, if you call capital X, which is your discrete random variable, the number of zombies out of those 9, and knowing that this is a binomial distribution with number of trials 9 and probability of success 0.19, what you're actually trying to find is the probability of X being less than or equal to 3, at most 3, so it can be 3 or less. This is approximately 0.927 rounded to 3 significant figures. Now let's say that 3 of those people, they are zombies. You found a suitcase with 5 vaccines against this disease and you're willing to try it in these zombies. The label reads, the efficacy is 52%. Some assumptions for this exercise. You can tell whoever is a zombie. If you need, you can give zombies more than 1 shot, and also you can instantly tell whether the shot worked. Meaning they suddenly stop becoming zombies. So they're not zombies anymore. They look like normal people. Now, what is the probability that you're able to cure every zombie with the 5 available shots? Well, from these 5 shots, at least 3 of them, they have to work. And we have a different discrete random variable now, which we're going to call capital Y. So capital Y is the number of shots that work out of those 5. We also have a binomial distribution with n equal to 5 and the probability of success 0.52. We want to know what is the probability of y being greater than or equal to 3, which by the way, if you're using a TI-84, you might want to do 1 minus p of y less than or equal to 2. So this gives you approximately 0.537. Now on to the hardest question. How many shots would there need to be in the briefcase in order for the probability of all 3 zombies getting cured to be at least 99%? Well, the probability of curing every zombie, all of 3 zombies, if we have only 5 shots, we just calculated that, it's 53.7%. It makes sense that having more shots would increase the probability of curing everybody, of course. So the question is, how many shots do we need in order to raise that probability to 99% or more? To define a new discrete random variable, which is the number of shots that work, but right now it's out of n, and we're going to calculate n. Our w is also a binomial distribution, n, 0.52. And we will like the probability of w being greater than or equal to 3 to be at least 99%, so 0.99 or more. Which, by the way, means that w being less than or equal to 2 should be less than 0.01. Now, you could definitely guess and check and try a few numbers for n and check the results in your calculator until you get something which is less than 0.01, or you could create a table to do just that. And if you do so, you are going to notice that for n equals 12, the probability of w being less than or equal to 2 is 0.0137. which is not quite there. Now for n equals 13, we have 0.0077. Therefore, the briefcase should contain at least 13 shots. In this last exercise, we have a kinematics question, one that involves the velocity defined as a piecewise function and concepts such as speed or displacement. But by all means, this is not a particularly hard one. And by the way, we can use the GDC for this one. This is a paper 2 question, so shouldn't take that long. We have a particle initially at the origin, which is moving according to this piecewise function. Now, one thing that you can do, which saves a lot of time, is to graph these two pieces of the piecewise function and then take that and create a sketch to be used in your question. And we're gonna do just that. We're going to input these two pieces, so 6x, which by the way, x represents t, minus t squared. And then we have 25 minus 4 times x. For our window, we can use -1 and let's say 12. And for y, we can go as low as -20 all the way up to, let's say, 10. And when you trace these, you get these two graphs. Now, the intersection should be at t equals 5. And that's exactly what happens. When t is equal to 5, the velocity, coincidentally, is also equal to 5. Now, when we transfer these two graphs to our sketch, we need to select the right portion of each one of these two curves. So from 0 to 5, we have the parabola. And after 5, we have the line. And if we want to find the greatest speed from 0 to 5, given that the speed is the absolute value of velocity, but from 0 to 5 the velocity is positive, we can just find the greatest velocity, which happens on the vertex. And in this vertex, which is located at t equal 3, and the velocity there is 9, we have the velocity, as I mentioned before, as 9 meters per second. So that is the greatest speed. Now, considering that the particle is initially at the origin, we need to show that the distance of p from the origin when t is equal to 5 is 100 over t. Now, if this is the graph of velocity, we can find the displacement, which will represent the distance from the origin, by finding this area over here. So we need to integrate from 0 to 5 the first piece of this function, which is the quadratic. So 6t minus t squared dt, which you can find using the calculator or by integrating manually. And given that this is an easy integral, let me just do this manually. So we get 100 over 3. Now for the most interesting question here, hence find the time t when the particle returns to the origin. Now we can see that from 0 to this time, which we're going to call t1, the displacement is positive, which means that if you were to draw a motion diagram, and this being the origin, and the motion diagram being positively orientated to the right, we would start over here, and up to t1 we would be distancing ourselves from the origin. Let me call this point A as well. So A represents the distance from the origin. Now we can find t1, which is basically taking the equation of the line, which I'm going to color code green, and equating it to 0. So 4t is equal to 25. When t is 25 over 4, which is our t1, the particle is integral 0 to 25 over 4, 6t minus t squared dt, meters from the origin. And for this, of course, you can use the calculator. We get approximately 35.8 meters. So this point A represents 35.8 approximately, and after that, we can see that the curve is below the x-axis, which means that the object is going back. And it will go back to the origin exactly when the red area is equal to the purple one, given that the area represents the displacement. So let's call this t2. Whenever the integral from 25 over 4, which is our t1, to t2 of the equation of the line, 25 minus 4t dt is equal to 35.8, that is when the object will return to the origin. Now we need to solve for t2. Now just one small adjustment, we need to account for the fact that the integral is negative. So the calculator will find the integral negative because it knows that the curve is below the x-axis. So you need to adjust the sign. You can either place a negative sign before the integral or before the 35.8 like this. And when we do so, we get t equal to 10.519 dot dot dot. So approximately 10.5 seconds. And that is it. Question C was much more tricky, or much trickier than questions A and B, which were super fast. All right, so week number 8 is done. We just have 2 more to go, so 2 weeks to go, which means that your IB math exam is approaching. Don't freak out, we still have 2 more weeks to study together. I'll see you next week.